Question. Minimize and maximize z is equal to 5x plus 10y subject to the constraints x plus 2y is less than or equal to 120. X plus y is greater than or equal to 60. X minus 2y is greater than or equal to 0. X and y both are greater than or equal to 0. Show that the maximum of z occurs at more than 2 points. Solution. To maximize or minimize the given function with respect to the given constraints, we will use the following algorithm. The given function is, and the given constraints are. Let us start with the first step. For this, firstly, we will draw the regions satisfied by the inequalities 2 to 5 and then find the common region. By inequality 5, we have x and y both are greater than or equal to 0. So, the required region lies in the first quadrant. Now, we will find the region satisfied by the inequalities 2 to 4 and lying in the first quadrant. To draw the region satisfied by the inequality 2, we consider the corresponding equation of inequality 2, that is, x plus 2y is equal to 120. The solution set for this equation is given as follows. When x is equal to 0, then y is equal to 60. And when y is equal to 0, then x is equal to 120. Plot these points on the Cartesian plane and join them with a straight line. Here, the line x plus 2y is equal to 120 divides the xy plane into two regions. To find the region satisfied by inequality 2, consider a point 0, 0 not lying on the line x plus 2y is equal to 120 and put 0, 0 in the inequality x plus 2y is less than or equal to 120. We get 0 plus 2 into 0 is less than or equal to 120, which implies 0 is less than or equal to 120, which is true as 0 is less than 120. So, the region which contains 0, 0 represents inequality x plus 2y less than or equal to 120. To draw the region satisfied by the inequality 3, we consider the corresponding equation of the inequality 3, that is, x plus y is equal to 60. The solution set for this equation is given as follows. When x is equal to 0, then y is equal to 60. And when y is equal to 0, then x is equal to 60. Plot these points on the Cartesian plane and join them with a straight line. Here, the line x plus y is equal to 60 divides the xy plane into two regions. To find the region satisfied by the inequality 3, consider a point 0, 0 not lying on the line x plus y is equal to 60 and put 0, 0 in the inequality x plus y greater than or equal to 60. We get 0 plus 0 is greater than or equal to 60, which implies 0 is greater than or equal to 60, which is not true, as 0 is less than 60. So, the region which does not contain 0, 0 represents the inequality x plus y greater than or equal to 60. From figure, we can see the region PABP is common to inequalities 2, 3 and 5. To draw the region of inequality 4, we consider the corresponding equation of inequality 4, that is x minus 2y is equal to 0. The solution set for this equation is given as follows. When x is equal to 0, then y is equal to 0. And when x is equal to 20, then y is equal to 10. Plot these points on the Cartesian plane and join them with a straight line. Here, the line x minus 2y is equal to 0 divides the xy plane into two regions. To draw the region satisfied by the inequality 4, consider a point 10, 0 not lying on the line x minus 2y is equal to 0 and put 10, 0 in the inequality x minus 2y greater than or equal to 0. We get 10 minus 2 into 0 is greater than or equal to 0, which implies 10 is greater than or equal to 0, which is true as 10 is greater than 0. So, the region which contains 10, 0 represents the inequality x minus 2y greater than or equal to 0. From figure, we can conclude that the common region of the system of inequalities 2 to 5 is given by A, B, C, D, A. Step 1 completes here. Now, we will follow Step 2. Here, the feasible region is bounded and corner points are A, B, C and D. From figure, it is clear that the coordinates of points A and B are 60, 0 and 120, 0 respectively. C is the point of intersection of lines x plus 2y is equal to 120 and x minus 2y is equal to 0. By solving x plus 2y is equal to 120 and x minus 2y is equal to 0, we get x is equal to 60 and y is equal to 30. So, the coordinates of point C are 60, 30. D is the point of intersection of lines x plus y is equal to 60 and x minus 2y is equal to 0. By solving x plus y is equal to 60 and x minus 2y is equal to 0, we get x is equal to 40 and y is equal to 20. So, the coordinates of point D are 40, 20. Hence, the corner points of the feasible region are A with coordinates 60 and 0, B with coordinates 120 and 0, C with coordinates 60 and 30, and D with coordinates 40 and 20. So students, do you remember what is our next step? Yes, now we will find the value of the given function at these points. The values of z is equal to 5x plus 10y at these corner points are as follows. When x is equal to 60 and y is equal to 0, then z is equal to 300. When x is equal to 120 and y is equal to 0, then z is equal to 600. When x is equal to 60 and y is equal to 30, then z is equal to 600. And when x is equal to 40 and y is equal to 20, then z is equal to 400. Here we can see that the minimum value of z is 300, which is given by corner point A with coordinates 60, 0. And the maximum value of z is 600, which is given by corner points B with coordinates 120, 0 and C with coordinates 60, 30. Since the line segment BC lies in the feasible region and all points on this segment give the same value of the given function, so the maximum value of z is 600, which occurs at all points of line segment BC. Hence, proved.